What is up, everyone? My name is Garreth, and this is the 5th entry into the Cloaked Protocol Devlog diaries. In this devlog, I solved the issue with managing enemy types, weapon types, and level progression access. For those new here, Cloaked Protocol is a stealth action espionage game where you take control of a special agent to infiltrate a secret organization in an attempt to stop their plans. In this devlog, I wanted to tackle a few things that I've been putting off for a while. I wanted to ensure that I can make enemies in all shapes and sizes with different attributes and as simple as possible. I also wanted to start the process of having weapons shoot and apply damage to the enemies so that I can start thinking about building a block-out prototype and putting it into the hands of the players. I also took on the task to work on level access for progression. So without waiting any further, let's get right into the devlog. My goal is to develop a modularized approach that emphasizes the creation of reusable and generic scripts that can be utilized by anyone or any project. The approach involves breaking down the game development process into small and reusable components that can be used in multiple games. This strategy can significantly reduce the development time, save resources, and make the game development process more efficient. For a great example of adopting the modularized process to speed up game development, we can take a look at Naughty Dog's Uncharted series. Uncharted 1 took 2 years to develop. Uncharted 2 took 1 year and 10 months, with 6 months of that just being pre-production. Uncharted 3 was released in 2011 and the development started in 2010. For each of every installment, the team managed to reduce the development process. With the leap of technology and the process changes, Uncharted 4 took 4 years to make. With that little distraction out of the way, creating an enemy controller script is one of the many components that make up the modularized approach. The enemy controller script is responsible for controlling the behavior and the attributes of the enemies in the game. It defines the enemy's health, speed, armor, attack range, base damage, attack frequency, and crit hit chance. By using a script, I can customize each enemy behavior and attributes without having to rewrite the code for each enemy. With this approach, I get to just apply the enemy controller script to anything from trees to walls to NPCs, and that game object becomes the enemy. One of the main challenges in developing the enemy controller script was creating a script that could be used for different types of enemies. I needed to ensure that the script was generic enough to accommodate the different types of enemies in the game. To solve this challenge, I decided to use scriptable objects. For those that have seen my previous devlogs will know that I really like scriptable objects. They are a type of asset that can be used to store data and scripts. So, I am using it to store item pickups in the world, enemy attributes, weapon attributes, including base damage the weapon can deal, the amount of bullets the magazine can hold, the max bullet stack amount the player can hold. By creating an enemy-based scriptable object, I can assign it to the enemy controller script, allowing me to create multiple enemy variations with ease. Using scriptable objects has several benefits. Firstly, it allows me to create enemies with different armor levels, attack frequency, and damage amounts, which can add more variety to the game. Secondly, scriptable objects are easy to update and modify, allowing me to make changes to the enemy attributes without having to edit the script. This also applies during runtime of the game. When you stop running the game, the changes will stay. Lastly, it makes the code more organized and easier to read, which can save time and effort in the long run. Overall, using scriptable objects have made the development process much more efficient. Before we continue, it would be amazing if you could hit the subscribe button, click the like button, and turn on the notification bell. It really helps the channel grow and will keep you in the loop for when I publish new videos. Feel free to leave a comment, question, or suggestion in the comment section below. I have also set up a Discord channel for those wanting a place to hang out, or for those that want to learn, seek help, or share your progress with others. You can find the link in the description below. Thank you so very much for your support. The next thing that I spent quite a lot of time on is the shooter controller. The shooter controller is a crucial component in any shooting game, responsible for handling the logic behind firing the weapon and applying damage to the enemies. In my shooter controller script, I utilize hit scan technology to determine whether a player has successfully hit an enemy or not. Get ready, because I'm going to get a little technical for the next minute. The code makes use of an onEnable and onDisable method to subscribe and unsubscribe from an event manager that is triggered whenever the player uses a tactical item. This event in turn calls the getHitScanResult method, which calculates the position of the mouse in the game world and sends out a raycast in that direction. If the raycast collides with an enemy, the shooter controller applies damage to the appropriate body part based on the hit location. The applied damage method takes in two parameters: the collider that was hit and the base damage of the weapon being used. Using the enemy controller's calculate hit location method, the shooter controller determines which body part was hit and applies damage to that part based on the appropriate multipliers. The script uses a switch statement to check which body part was hit and applies damage accordingly. What's exciting about this code is that the applied damage method can be reused for any enemy in the game that utilizes the enemy controller script, which means that the enemies can have different types of damage multipliers applied to their limbs, head, or torso. This opens up a wide range of possibilities for designing enemies that require different tactics to defeat, making combat more engaging and challenging for the player. Additionally, the use of scriptable objects to store weapon properties means that the shooter controller can be easily customized to suit the needs of different weapons without having to modify the code itself, making it a highly modular and reusable component. Next, I would like to address why this video was 2 months in the making. It was primarily due to significant architectural code changes that I had to undertake. In an effort to enhance the functionality and efficiency of the project, I ventured into uncharted territories and I experimented with various approaches to managing the Unity scripts and codebase. Needless to say, this exploration led to a series of unforeseen obstacles and learning curves. During this process, I delved into the realm of dependency injections and stumbled upon a tool called Zenject. Zenject is a powerful framework that aims to simplify the management of dependencies in Unity projects. Its goal is to decouple components, promote modularity, and enhance testability by injecting dependencies into the object dynamically. However, as I delved deep into Zenject, I encountered a few roadblocks that made me reconsider its implementation. The framework presented an overwhelming number of complex options, which provided to be a challenge to navigate and configure effectively. Furthermore, I discovered that the project has been abandoned in 2020, raising concerns about long-term viability and support. Despite extensive online research, I found limited resources and a lack of community support, making it difficult to troubleshoot issues or to seek guidance. In conclusion, the journey of creating this video was a challenging one, primarily due to the architectural code change I undertook. Although I initially explored Zenject as a potential solution for managing dependencies, its complexity, lack of support, and abandonment led me to seek an alternative approach. Through careful consideration, I settled upon a hybrid pattern that incorporates the observer and singleton design pattern, ultimately allowing me to overcome the obstacle of creating robust and functional code. Finally, for this devlog, I implemented a progression lock system. That's just a fancy way of saying that I implemented locks and doors. This adds a new level of complexity to the gameplay. With this system, I can create doors that require specific items to be collected by the player before they can be opened. This could be keys, certain items, weapons, or any number of objects. To use the system, I added a single script to a trigger collider and then attached a scriptable object to that collider that specifies the access item required to open the door. The script then checks if the player has collected the required item and has it in their inventory. If they do, the doors will unlock, and the player can progress to the next area. If not, the player will need to go back and find the required item before they can proceed. The system adds an extra layer of fun to the game. The byproduct of the lock system is that it's a simple but effective way to verify if certain items are found. This could then possibly be used for Steam achievements, adding extra unlocks or in-game bonuses. It encourages the player to explore the environment thoroughly and search for hidden items that they may require to proceed. It also adds replay value to the game, as a player may need to play through multiple times to find all the secret items should there be any. Overall, the lock and key system is a crucial addition to Cloaked Protocol as it enhances the game's tactical espionage action gameplay. It provides players with more immersive and challenging experiences, while it also rewards them for exploring and thinking strategically. Overall, the primary objective of this project is to learn game development and create an enjoyable experience for the player. As a first-time game developer, I want to create a game that would be both entertaining and compelling. My main focus is to acquire game development skills and knowledge. I hope to utilize what I learn in future game development projects. Well, that is it for this devlog. I really hope you guys enjoy seeing a bit of the progress. Just a reminder that I post daily updates on Twitter and Instagram, so please go check that out. Thank you again for joining me on this ride, and I'll catch you in the next video. Bye.